Thank you, Dr. Tariq, and I thank Dr. Rashid and Alum Business Congress for inviting me to speak. I'm going to be talking about something I've been involved in research for about 40 years, and I've been at Fairleigh Dickinson University, and my colleague, Dr. Hillel, mentioned he's starting a degree program, a BS degree in desal engineering, and at Fairleigh Dickinson in 1970, we were the first university in the United States to start a bachelor's degree in desal engineering. Okay, so I'm going to be talking about reverse osmosis, making it more energy efficient by controlling membrane fouling with a hybrid design. Okay, so the ocean is there, we need energy, and we're going to be talking about the desalination process of reverse osmosis, which will produce the fresh water. The brine is then taken back into the ocean, and so we have two things. We're producing fresh water, and we're producing using energy to do that through the reverse osmosis process. The reverse osmosis process is very simple. You have seawater on one side of a membrane and fresh water on the other side of the membrane. Normally, because of the second law of thermodynamics, the water should move from the freshwater side to the seawater side. But we want the water to move in this direction, so we apply a high pressure to the seawater to move it across this membrane. Now, if the seawater just contained salt, there wouldn't be any problem with this reverse osmosis process. But what I'm going to be showing is that seawater contains organics and bacteria, and these organics and bacteria will associate together to form a fouling layer on the membrane based upon how one designs the RO membrane. Now, today, reverse osmosis makes up, in terms of the total desalination pie, about 53%. So it's a pretty active market, and you see the thermal processes. At one time, MSF was great, but it's declined. We have MED and vapor compression, but most of the processes that are used today are the reverse osmosis membrane, 53%. And in terms of energy consumption, Dr. Hillel pointed out that the reason people look for reverse osmosis is because if you look at the total energy, equivalent energy, reverse osmosis is 3 to 5.5 kilowatt hours per cubic meter. And you look at the MSF, it's 13, 25, 6.11. The thermal process is more energy intensive. So people are now focusing more on the reverse osmosis process because it requires less energy. The problem now, and what I'm going to be talking about, is that the reverse osmosis process is more prone to the fouling of the organics and the bacteria in the seawater than the thermal processes are. So this number is based upon if the seawater only contained the salts and the gases and did not contain organics and bacteria. Same slide as Dr. Hillel. But basically, seawater contains these phthalates in it. Okay, so here are pores in the RO membrane. Water, of course, will go through the pores under high pressure. But what happens is that the phthalates, both the bacteria and the organics, assemble into what's called a fouling boundary layer, okay? And what we refer to as a concentration polarization layer, that the bacteria and the organics are going to become concentrated on the membrane surface. Not adhere to the membrane surface, but become concentrated, compared to the bulk flow, which is a high velocity Concentration polarization depends upon two things: the flux that is going through the amount of water you produce and the cross-flow velocity that you maintain across the membrane. Today, these membranes are very high permeable membranes. When I first started in this field, the membranes produced about half the amount of water that they produce today. But the problem that has developed is that with the use of these highly permeable membranes, this concentration polarization layer has become greatly increased, and that has caused more and more of the fouling of the organics and the bacteria onto the membrane surface.